Hi, good morning. I am Bathaei, a graduate student at Department of Civil Engineering at University of Texas, Rio Grande Valley. I am conducting a research with advisory of Dr. Mohammed Abdulrahim. My topic is framework for decision support system for evaluating the different strategies available for mitigating urban heat island effect. Urban heat island effect can be a major concern due to its detrimental impacts on the society, environment, and economy. And with no comprehensive system that consider various parameters in qualifying and the selected strategies for mitigating the effect of UHI, this research aims to identify, classify, organize the different parameters and actually the current mitigation strategies and form a decision-making framework and describe and compare other possible multi-criteria decision-making methods, select the most feasible one to analyze the data. And for this purpose, we developed urban heat island mitigation strategies framework and a system dynamic which describes this framework, and finally, a decision support system, which is further supporting performance evaluation and governmental decisions for urban heat island mitigation. Urban heat island effect, or UHI, is relative air temperature increase in developed areas compared to undeveloped areas. As you can see that mostly in megacities, we have some heat released from vehicles, from road surface, from hard surface, from building surface, and some anthropogenic heat, which they increase the temperature in our current cities in with compared to suburban areas or rural areas. So there are some methods that can mitigate this, and this heat can be reduced by via vaporization. They can be reduced via using light coil materials, using urban forestry, more vegetable and vegetation and trees in the cities. So there are different kinds of methods, which in the next slide we can describe the some most current these mitigation techniques, and we organize them mainly in three main groups: urban forestry, um, and the other one is cool or high-tech materials, and evaporative techniques for water features. The methodology, this study aims to develop a framework with respect to sustainability and resilience parameters based on the literature review. So collectively, the hierarchy will provide the main skeleton for developing a comprehensive decision support system for selecting the most suitable UHI mitigation strategies. The criteria which are listed in a hierarchy, then they are listed in based on two main groups of sustainability and resilience. In the other levels of hierarchy, sustainability are divided in three main groups of economic, environmental, and social, and resilience are in two other groups of vulnerability and resistance to change. The last level of hierarchy has listed the most common and relevant mitigation strategies we can use in assessing them. The system structure presents a true description of the methodology adapted in developing a framework for decision support system for evaluating urban heat island mitigation strategies. It has three main components: the user interface, system main engine, and output and display. For example, the user interface is the main function of it is the act to collect the data, where all the necessary data are collected and prepared to be processed using spreadsheets. The main engine is responsible for carrying out all the operation as a part of the evaluation process of the alternative and up to fulfillment of the objective of the system. And it is designed to use weighted scoring method as accommodating certain matrices for evaluating different strategies, which in the next slide I will explain why we decided to use weighted scoring method as a methodology for analyzing. And the final output is displayed in spreadsheets again. And the advantages of these spreadsheets are their effectiveness in handling various number of data in terms of organization, modification, large capacity, and consistency. Multi-criteria decision-making is an appropriate approach for decision-making problems. Several methods have been proposed for decision-making for multi-criteria decision-making. Among them, we choose three of them: analytical hierarchy process, weighted scoring method, and analytical network process. We describe them and we find the compare them on the weaknesses and the strengths of each of them, and based on benefits and shortcomings of each method, and based on the feasibility and limitation of this research, we finally decided to choose weighted scoring method as the methodology. The flowchart of this weighted scoring method is to set qualitative and quantitative criteria. We narrow down them based on their relevance and their applicability, and find the relative weights of these criteria in previous comparisons. And based on the set of alternatives we have, we evaluate alternatives against each criterion. Finally, we calculate the ranking score for each alternative, and of course, the alternative which has the highest score, or the combination of the highest scoring alternative, will be the result. Although there must be various criteria which have contribution in assessing the strategies of urban heat island mitigation, it is impossible to include all of them based on all of them. So this research developed a hierarchy based on sustainability and resilience in assessing the urban heat island mitigation strategies. And this hierarchy is the main skeleton of the DSS framework, and this framework is envisioned as a knowledge-sharing platform supporting stakeholders like urban planners, architects, decision makers, and policymakers in the extraction of the most suitable urban heat island mitigation strategy. Thank you for your attention. End of this presentation.